This video will introduce you to how to use Multisim Live, which is a circuit simulation that we'll use in lieu of actually building a physical circuit. So the first thing that you'll need to do is to create a account with Multisim by going to the website multisim.com. Once you create your free account, use your Ursuline email address as you're doing so. You'll then want to log into your account. And after you log in, you should see a screen similar to mine. I can see at the top that I'm logged in where it says hello and my username. And I'm going to click on Create Circuit. This simulation uses the symbols that are internationally accepted for circuit diagrams. And you can find all of the circuit elements that are available to you on the left-hand side here. We know that one of the things that every circuit needs is a power source. And you'll notice that as I put my mouse over that third symbol down, it comes up with that word sources. When I click on it, I see lots of different options. But for this project, the energy source that we'll be using is AC voltage. That's the same type of energy source that comes into your houses. When I click on that, I see the symbol show up and I can place it anywhere on my board here. And so I'm just going to pick a random spot to place it. Once you have placed it, you are able to move it around. So if you find later that maybe where you put it was inconvenient, not a huge deal. You can totally move that around. A couple of other things to note. Every element that you put into your circuit is going to be labeled with a name. So this has a name V1. And then it also gives you some information. So this is a 1 volt energy source, and it is alternating at 1 kilohertz or 1,000 times per second. Now, we know that our voltage source for our tiny house is not going to be 1 volt, but instead it's going to be 120 volts. So I can double click on this window, and you'll see that now I get something different on the side here. And I can change the voltage either with this slider, or I can change it in the menu off on the right hand side here. If I change it with the slider, if I go all the way up, you'll notice that it maxes out at 10 volts here. But if I click that times 10, it then maxes out at 100, and I could change it between 0 and 100, or if I were to click times 10 again, it maxes out at 1,000, and I can change it between 0 and 1,000 with my slider. I can also directly change it on the right-hand side here by saying 120 volts and clicking enter. And that'll change it as well. And then to remove this box that came up here, I just need to click off of the element. Again, you can also rename it. So I mentioned to you how this was called V1. So up in the top here, it says ID. I could call that voltage, source. You cannot use spaces. That's why I got that error message there. In all honesty, I really don't care what you name that. I can also get directly to it by double clicking just on that name voltage source, and then I see the screen up here instead of having to go on the right hand side. So I'm going to go back to V1 where it was before. We also know that we're going to be working with light bulbs. That's the first thing that I've asked you to work on designing is the placement of your bulbs in each of the rooms. And so this symbol that you see right here is a symbol for a light bulb or lamp as they're calling it. And so I'm going to click on that, and I'm going to place a lamp somewhere on my circuit here. Now I can change this bulb a bit. Right now it's kind of horizontal, but I could change that by clicking this little rotate button to make it vertical like this if you wanted to, if that was convenient for your design. Much like what we saw with the voltage source, I can change the name. So let's say that this was a bulb in the kitchen. I'm going to label it as such, and that way I can keep straight where this is located, and to know the uh, maximum rated voltage that's going to be something you're going to have to figure out a little bit. But we do know that each of these are going to be 60-watt bulbs. And so again, you'll have to do some calculations and figuring out what that voltage would be, perhaps doing some research to figure out the common burnout voltage for a standard 60-watt bulb. So I have that bulb in place, and I know that I'm going to want a switch as well. You can see underneath the symbol for a light bulb, a common symbol for a switch. And the switches that we'll be using here are called SPST switches. That stands for single pole, single throw, as opposed to things like SPDT. You see that symbol here where it is a single pole, double throw. An example of this, something that would use an SPDT switch, would be if you have something that has like a high and low setting and you're switching it from high to low. When things are just on and off, it's pretty much a SPST switch. So I'm going to stick that somewhere randomly in here. Really not much to edit with that other than its name. I'm going to name it kitchen lights. So that way I know what I want that switch to control. Now I need to connect these all to create an actual circuit, and connecting your elements is really easy in this case. So to connect from my voltage source to my switch, I'm going to click on this little dot here. You'll see the symbol of my cursor changed a bit to kind of like a little thing looking like a wire. And no matter where I go on my screen, notice how it's always using right angles. That's really important in circuit diagrams. And then when I get to this other spot, it kind of gives me an indication that I'm making a connection there. And then I just click again, and all of a sudden put a wire in the place there. I'll do that with each of these connections to connect my circuit and create a complete circuit here. Once you create that complete circuit, there's not going to be a whole lot that happens. Now, clicking on the switch, where I have this thing that kind of looks like a target. If I put my mouse over it, it says toggle. That closes and opens the switch, as you can see here, but that's not really going to do a whole lot. And so using that, it doesn't actually show you what happens in the circuit. What we really want to look at, if we want to see what's happening in the circuit, is to go to this interactive step. And really what I want to do is press this play button. And notice when I put my mouse over that, it says run simulation. Now, every single time you run this simulation, unless you've already taken care of this, you're going to see this error message over on the side here that says no ground node was found. If you're thinking about wiring a house, it's really important to provide a path to the ground. That's a safety feature. And so to get rid of that error message, I'm going to put in a ground. This symbol right here is the symbol for a ground, and you'll see that it's right here labeled as ground. And it's good practice to connect that ground close to the negative side of your voltage source. So that's where I put it there. And so now when I click run, that error message goes away. Get rid of this little bar over on the side here. I clicked that info button to get rid of it. Now, since I am running a simulation, when I close my switch, and all I have to do to close it is click on it now, it all of a sudden shows me what's actually going to happen. Now, you'll notice this kitchen light was set to have a burnout voltage of 15 volts. Its maximum rated voltage was 12 volts, but I connected it to 120 volts. So you'll notice the symbol changed. All of a sudden, I no longer have that little curly Q that I would typically see in a light bulb. Instead, that light bulb burned out. Just as if we were in the real world, when a light bulb burns out, you have to change it out. And so that's what we're going to have to do here. So I'm going to stop my simulation by pressing that stop button up on the top there. And I'm going to click on this light bulb and I'm going to delete it. Notice that also deletes the wires that were connected there. I'm going to do another light bulb here and rotate it like I had it rotated before. This time, let's see, this is kitchen. This time, just to show you what things look like, I am going to change it so that its burnout voltage is 120, and I'm going to say 100 is the maximum rated voltage. Maximum rated voltage would refer to what is recommended as the maximum voltage you give it versus the burnout voltage means that above that it's not going to work. Let's actually change that. Let's change the burnout voltage to be 130 and that maximum rated voltage to be 120. So I want to connect this again, just like we did before. Connecting, didn't get a good connection there. Connecting wires. So I have my complete connection again, and I'll hit my play button. What happens this time when I close the light switch? All of a sudden now, instead of burning out the bulb, I got rid of it. I still have that zigzag there. My bulb is lighting up. Now you may also notice that my bulb is flickering a bit. That has to do with the fact that it's running off alternating current or AC current, where that current is changing directions, and that can actually that does cause light bulbs to flicker. Now in the real world, they flicker so fast that we can't actually see that they are flickering. But perhaps you've seen a standard light bulb flickering if you've ever taken a slow-mo video. That would be what causes it, is that alternating current there. And if I open my switch, notice that my light bulb goes out. So this concludes the introduction to this tool that we'll use. Now, obviously, there's still a bit more to do. I will come in at a later time and give you some information about how we'll model the outlets that I told you that each room was required to have. Oh, and I actually lied. This doesn't end the simulation because there's one more thing I wanted to show you. And that one last thing I want to show you is a fuse, since you're required to have fuses in there. Oh, fuse is under this resistor symbol, and because it's considered a passive element. So there's our fuse right there. And I can put my fuse into my circuit here. Notice that I have an option of what the maximum current is. So I gave you some values for those fuses. Make that little connection right there. And if I close my switch here, nothing happens with my fuse. Everything is good with my fuse. Now, I am going to purposefully change this. And I'm going to go back to saying that 1 amp is its maximum current. Show you a bit of what happens. Not even that. Okay. Let's go with a really low maximum current. So let's say 0.01 amps. That's such a low maximum current. What I'm going to do is make this fuse blow out just to show you what that looks like. So if I close this, all of a sudden this fuse went away because the current exceeded 0.01 amps. Much like a light bulb, when a fuse blows, you have to replace the fuse. And that's exactly how the simulation works. You'll have to click on that fuse you will have to delete it and then put in a new one. So that should take you through everything you need to do to plan out the layout of the lights in your tiny house. Again, I'll give more information about planning out the outlets, but I really wanted you to focus first on learning the simulation and playing around with that light configuration so that it works as it's supposed to. Let me know if you have any questions. And again, if there's something that you can't get to work, let me know. I'm happy to jump on a Teams call where I can actually see your computer screen and help you problem solve in that way.